Welcome to the Lionhearted Academy. My name is Richard Tai. Welcome back to our trigonometry lesson. Today we're going on trigonometry lesson 26, which is a part 5 of our lessons on graphs of trig functions. Now today we're going to start with several vocabularies. It's very important vocabularies that we need to understand when we talk about graphs of any trig functions. Alright, so let's talk about period, amplitude, frequency, and also there's a displacement. And so let's go ahead and talk about period. Now I have never really defined period yet, so I want to go ahead and at least define period, and then I will go ahead and show you what they are. So period is the time, alright, the time basically is the time it takes for a periodic function, periodic function to complete a full cycle. Okay, and what do I mean by full cycle? When we talk about full cycle, we're talking about that it goes through all its unique values and start repeating. Before it start repeating, it goes through all the values that it has gone through, and then the function starts to repeat. So basically the time, or you can talk about the time it takes for our periodic functions to start periodic functions to start repeating its values. Okay. Now this is not as precise as I would like to be, but we can take it for now. I'll go ahead and show you what they are later on the sine and cosine graphs. Then we can see the periods very clearly. Okay, now period and frequency, they are very much related. In fact, their relationship is a reciprocal relationship, because period is the time it takes to complete a cycle. Frequency is how many cycles it completes in a certain period of time, in a given period of time. So it's exactly the opposite of period. There is the relationship again is reciprocal relationship. Period is how long does it take to complete one cycle. Frequency is how many cycles it will complete in a given period of time, in one unit of time, perhaps. So there, of course, the relationship. We're going to see how frequency and period relate. But frequency is a very important measurement in our modern society, because we actually deal with frequency all the time when we deal with signals, electronic signals, radio signals, frequency. Whenever you listen to the radio, whenever you deal with wireless phones, cell phones, wireless computer Wi-Fi, your Bluetooth, everything has to do with frequency, because that's how we measure the frequency of a wave. That's how we use frequency to distinguish between different kinds of waves. They're different light waves, they have different frequency, different colors of light, they have different frequency, radio waves, microwaves, that they all have different kind of frequency. They all depends on how many cycles it completes in a period of time. Your electricity that you're using right now to watch this video, it has a frequency. If you're in the United States, the socket, the AC alternate current coming out of your socket is 60 hertz, about 60 hertz. But in other countries, it could be 55 hertz. And hertz means how many cycles per second. So 60 hertz means 60 cycles per second. Okay. Anyway, so we can talk about how many cycles. What does it mean to complete one cycle? So that's frequency and period. And amplitude, believe it or not, is also very much involved in waves. Amplitude. So when we talk about amplitude, we're talking about half of the maximum, half of the difference between the maximum and minimum value of the wave. of the function. So amplitude is half of the distance between the maximum and minimum wave, or half of their difference. So when you have the maximum value of a function, you have minimum value function, you can subtract them, and then half of their difference is your amplitude. Okay, half of the difference is your amplitude. This is how much distance there's from amplitude to this. Now there's another thing called displacement. Displacement is half the sum of the maximum and minimum value of the function. We'll come back to this. Okay, we'll see how exactly what they mean when we look at the graph. Now, but amplitude is a very interesting thing. But amplitude, if you think about this, amplitude is kind of like how loud or how small, how loud or how quiet your music is. Because music is wave, is sound wave. So the frequency of the sound wave can represent the pitch, how high the tone is or how low the tone is. But the amplitude is the loudness of the tone. So the amplitude is kind of like the volume. You can adjust the volume, increase the amplitude of the music. You decrease the volume, you decrease the amplitude of that musical sound wave. But frequency, it is the pitch. The higher the pitch, higher the frequency, the higher the pitch. Lower the frequency, the lower the tone. Okay, and also frequency amplitude I've used in our modulations. So have you ever wondered what FM radio means, or what AM radio means? Well, FM radio means frequency modulated radio signals. Amplitude AM means amplitude modulated. Okay, so they have their special. Each of their the FM radio and AM radio have their properties that in which they're better used for. Like for instance, FM radios are better used for music because it is more clear. Okay, but however, for FM radios have a little bit less range than AM radio. So AM radio usually can be amplitude and modified can go a little bit further away. But so let's go ahead and take a look at the graphs and see what happens. Okay, let's define them on the graph and let's see. So this is a regular sine graph. Okay, let's go ahead and write the f of x equal to sine x. Alright, so it's regular sine. This is our x-axis and this is our y-axis. Alright, so what exactly is the period? How do you determine the period? Well, if we start with any point, it doesn't have to start with 0. If I start with this point, okay, it starts with 1. Alright, now when does it come back to 1 next time? How long does it take to come back to 1 after it has gone through all the unique values of the function? So it's gone through pi, -1 down here and down here, right? So if you go from peak to peak, if you take a look at from the peak of the wave from peak to the wave, this is going to be your period. This is how long it takes for you to complete the cycle. So this is called the period of the function, and in this case it's 2 pi. Okay, it's 2 pi because it goes from pi over 2 to 5 pi over 2. So that's 1, 2, 3, 4 pi over 2, which is 2 pi. Okay, each division here is half a pi. So it's half a pi, two halves of 1 pi, so it's 1 pi, and the 1 and 1 half, 1 and 1 half, and then 2. So this is 4 halves. 4 halves is 2 pi. So the period, if you count any graph, if you count period, you can always go from peak to peak or trough to trough. Okay, trough to trough will also be very interesting. Now, if you go from midline, okay, this, by the way, this middle line here, the x-axis, serves as the midline. Now, why is it called a midline here? Because it is in the middle of the graph. Okay, there's always a midline in sine and cosine functions that are very important. If you go from midline, it's going to be a little tricky because you go from 0, you say, oh, if I go from 0 to 0, that's one period, right? Because it completed. Well, it's true, it did return to its original value 0, but that's not one period. Why? Because it hasn't gone through all the unique values of the function yet. So if you go from 0, you have to go up to the peak, come down to the trough, and then come back to 0 to the midline again in order for you to say, oh, I've completed one period. So if you go ahead and count from midline to midline, you really need to make sure that you have passed or at least a peak and a trough. in this case of sine functions. Okay, so period. Now what is the amplitude? So the amplitude is half of the distance between the maximum and minimum. So it's 1 plus half the difference between 1 and -1, right? So it's 1 minus -1. 1 minus -1, which is 2. 2 divided by 2 is 1. Or graphically, you can say it is the distance between the peak and the midline. Okay, the distance between the peak and the midline, this is your amplitude. Or the distance between the midline and the trough, that is also your amplitude. Okay, so there are several ways to look at your amplitude. From the midline, if you can identify a midline, the distance between the midline and the peak and the trough, that's your amplitude. Or it's half of the distance between the peak and the midline. Okay, so if I draw a line segment here indicating from the peak to the midline, from the peak to the trough, then that will be 2 amps. Okay, 2 amplitudes. So you take that distance, divide by 2, that will be your amplitude. Now your displacement is basically your midline. Okay, your midline is equal to your displacement. Okay, later on we're going to be using alphabets to indicate. So displacement and midline, they're the same. That's exactly what's going on in the middle. So what's going on in the middle? So usually I will use a dashed line in the middle to indicate that, okay, that's the midline, that's the line in the center, that's the average value. The displacement is, if you want to think of it, is the average value of the function. The average value, it always goes in the middle here, the displacement midline. Okay, so now we have period 2 pi. Okay, the amplitude in this case is equal to 1 units, because you go up 1 units, go down 1 units. Then you can see the total distance from the peak to the trough, from the trough to the peak, is 2 units. The difference, okay, 1 minus -1 is 2. So therefore, yeah, so you can see, I can write out here. So amplitude is maximum minus minimum divided by 2, right? So max is 1, minimum is -1, divided by 2, that will give us a 2 over 2, that will give us 1. So the amplitude is 1. Now the displacement is, mathematically we do it, is the sum, half of the sum of them between the max and the min. Alright, so in this case it's going to be 1 plus -1 divided by 2, but 1 plus -1 is 0. 0 divided by 2 happens to be 0. So that's why we have our midline at x equal to 0. So the amplitude is a number, okay, but the displacement is the position of your middle of the graph. So let's take so those are the 3 things: period, amplitude, and displacement. Now where's frequency? Well, frequency is the reciprocal of the period, in a sense, in this case. So frequency is how long does it take to complete 1 cycle. Well, if it takes 2 pi units, 2 pi time, 2 pi, because x represents the time of progression. If you go and draw the graph, it's like as time progresses, you draw the graph like this. So period is 2 pi, right? So it takes 2 pi units of time to complete 1 cycle. That means in every 1 unit, okay, in every 1 unit of frequency is actually 1 over period. This is reciprocal. So that means in every how many cycles does it complete in 1 unit of time? Well, it's going to be 1 over 2 pi. So that means in it completes 1 cycle in every 2 pi's of time. That's basically what happens. Period means in 2 pi's time it will complete 1 cycle. So it's 1 cycle. Frequency will be 1 cycle per 2 pi time. Period is 2 pi units of time per 1 cycle. So those are the 2 different ratios that we deal with period and frequency and period. Now it is the same thing for cosine. So this is a cosine function, okay, f of x equal to cosine x, okay, and this is your x-axis. So as you can see, again, if we go from peak to peak, okay, again, the peak to peak, the distance from peak to peak, let me use a different color now. The distance from peak to peak is again 2 pi, right? From 1 to 1 is 2 pi, and that is your period. We can use p to indicate that's a period. Alright, so the frequency of this function, again, frequency is 1 over p, is going to be 1 over 2 pi. Okay, So the frequency is 1 unit over 1 over p. That's basically the relationship. And the amplitude, alright, if you take a look at the amplitude, so from the midline, now where's the midline? So if I have the maximum at 1, minimum at -1, the midline has to be in the middle, between 1 and -1, so it has to be 0. So this is my midline, or my displacement. Okay, my displacement is going to be equal to 0, x equal to 0, y equal to 0 here. Midline is at y equal to 0, and the distance between the midline and my peak and trough is also 1. That's my amplitude. Amplitude is equal to 1. Okay, so again, the amplitude is equal to 1. All right. So now let's take a look at some other examples on the website. Let's go ahead and take a look at this. So we have an equation here I set up with different variables here, with different constant variables, constants, a sine bx minus c plus d. Now this is called the standard form for a sinusoidal function graph, sine and cosine. Okay, you can replace the sine with cosine. And each of the numbers here, each of the letter here, a, b, c, d, represents a number, represents a constant in the function. So when a equal to 1 and b equal to 1, we have a regular sine x, because there's no c and no d, so it's just sine x. So this is exactly what the graph of sine x looks like. Okay, let me go ahead and make it a little thicker so you can see clear. Now, what happens when we change the amplitude? When the amplitude changes, I would expect the graph to become wider in the y direction. Okay, so let's see. So as you can see, we change amplitude to 2. Now the midline is still the same, the period is still the same, but the displacement is still the same, which is the midline, which is d here. We'll see. So, but the distance between the midline and the maximum, the peak, and the trough has to be increased to 2. Alright, I can increase to 3. Okay, as you can see, I go down, increase to 4. As you can see, I can increase to 5. Alright, so this is something called the change in the amplitude. So the amplitude change is a vertical change. I can even go down. Well, if the amplitude becomes 0, there's no graph, right? It's just a zero. It's just a flat line. But if I do a negative amplitude, you can see that instead of a peak, right, a sine usually increases from 0 to 1. But in this case, if I do, but instead of going up from 0 to 1, it's going down from 0 to 2 first. But instead of going up from 0 to 1, it's actually decreasing from 0 to -2. Okay, so that's what the amplitude can do. Alright, so let me go ahead and adjust amplitude to 1. Let's take a look at B. B actually affects the period and the frequency. B is actually the direct relationship of frequency. It's related to frequency in a certain way. So this is higher frequency. As you can see, it's more packed, right? It takes less time to complete one cycle. See, one cycle is from here, from peak to peak. So now it takes less time to complete one cycle, so it's a higher frequency. If I go and reduce the frequency, it's less than 1, it's going to be a lower frequency, because now it takes more time to go from peak to peak. Okay, it takes more time to go from peak to peak. So higher frequency is a larger B number, it will be higher frequency, lower frequency. Now negative frequency doesn't make sense in a sense. It depends on the function, whether what does negative b mean, but it's still if you ignore the negative sign for now, it's still the same. Okay, if I go into -1, let me show you what happens. So this is -1. Okay, what happens, because sine of you remember a long time ago we talked about the opposite of sine, right? Sine of -x is equal to negative sine of x. So when you go to a negative b number, it just converts to a negative sign, so it goes down first and then come back up. Alright, so let's see, if I go back to +1, it goes positive. Okay, so it has the same effect of changing a and b to -1 on sine function. On cosine functions, there's no change, because cosine of -x is the same as cosine x. Now the c function is a phase shift. Phase shift is something we have not talked about yet, but let me show you the effect on the graph. As you can see, it seems like this graph is moving left and right. That's exactly what it does. It's called the phase shift. Okay, phase shift is moving the graph left and right. We'll talk about that a little bit more next time. D is vertical shift, which is the displacement. So we are moving the midline here up and down. We're moving the midline up and down, as you can see. Now this is something that you can actually come to this website and then set up the graph and play with it. Okay, just this is decimals.com calculator. You can type in A sine parentheses bx minus c plus d, and then it will give you a slider. Just add all slider, and then you will have a slider for all four variables, for all four constants, and then you can not constants but all four, yeah. Aperture, I mean properties here, aperture here, and then you can go ahead and slide them around to play around with it. There's another website called the graphical function exploration. Okay, you can also set up the equation like what I have done here: a times sine b times x minus c plus d. You can slide the amplitude, change the frequency, increase the frequency, decrease the frequency, change the phase shift. You can see what happens, and change the d value, which is the displacement or the midline. Okay, so as you can see, there's a lot of things that we can play around, but this does give us a very good idea of what is going on with the function. Okay, how can the function change in terms of the frequency, amplitude, frequency, which also affects the period. Okay, you see, because when I increase the frequency, I guess I forgot to mention, now I have a shorter period, right? From here to here, that's the time it takes to complete one cycle. It's shorter than if I say go from here, right? Here it will take longer to complete one cycle. So if I increase the frequency, I reduce the period. If I reduce the period, I increase the frequency. Alright, so I think that's enough information for today, but we definitely will come back, and I definitely suggest you to go to decimals.com and play around with it to see what kind of function you can come up with, and you can play around with the amplitude, frequency, and the period, increasing high frequency, lower frequency, something like that, phase shift, and then midline vertical shift, the midline shift. Okay, if you have any questions, please go ahead and leave it in the comment section, and then hopefully you'll join us again on the next lesson. Alright.